Right. Hello, everyone. Let's talk about closing the gap between blockchain and traditional gaming. So I'm Simon. I've been in blockchain since 2013, and I've been at it professionally since 2020 as a blockchain developer, but also as a blockchain architect. And currently, I'm the tech lead at PlayFi. We're about a team of about 20 people, and as I said, together we're trying to close the gap between blockchain and traditional gaming. So let's dive into what that means. So as you can see from this slide, Statista, Stretch Research, and Fortune did some research. And actually the gaming industry is booming. So the global gaming industry market is expected to grow towards $665 billion in 2031. And it's expected to grow for fantasy sports, a subsection of that, from $24 billion in 2022 towards 2031, towards $89 billion in 2031. And with that, we also see a growth of user-generated content. So Deloitte did some research, and they have found out that 3 popular video games, which are Minecraft, Roblox, and Fortnite, have enabled hundreds of millions of players to be these 3D creators. And they also expect that around $1.5 billion of US dollars will be paid out to these content creators in royalties in 2024 alone. Now, I think that's major because we're only talking about 3 games, right? So there's still lots of untapped potential here. But there is more. Gamers actually want to have more user experiences on top of their favorite games. And to make my point, I'll give you some examples. So you have these skin trading websites. You also have these game analytics websites. And you have these community wikis, and so on. But what's actually the problem? So the problem is that developers actually want to build these captivating open source experiences on top of their favorite games, but the traditional game studios and developers often provide no real tools to build modular experiences on top of their games. And that's because of a lot of reasons, but the most obvious ones are that there's a lack of resources, a lack of technologies, and priorities. So to give you some examples of that, for example, EA Games, but also Riot and Blizzard, have all put substantial amount of money and effort in setting up these analytics teams to analyze their games actually, but they're hesitant to open this up to the public, and even if they do, it's either for profit or in a limited fashion. So how can we then enable anyone to build these rich and modular experiences on top of their favorite games, right? So we've been thinking about this at PlayFi, and our vision is actually very similar to the one you have in DeFi with these money Legos, where you can use these open and modular and trustless applications, which you can stack on top of each other to build new, exciting experiences that you could not have built otherwise. So we want to extend this actually to games. So imagine that you can take the game data from Fortnite or League of Legends, smash them together, and then create these new gaming experiences that are very novel. That's our goal. So towards this end, we've been working on creating this solution at PlayFi, which I will go deeper into in the following slides. But I already want to give an overview of what we are working on. So at PlayFi, we actually allow anyone to build or to upload their own game data to our platform. And then a data processor can process this data. And we actually allow any type of game data, right? So the most obvious one is obviously video, but we also allow, for example, text formats or images or even audio. Once this data is processed, it will be transformed to the standardized text format and will be stored in our decentralized storage layer. And from there, these gaming applications, or gApps in short, as we call them, can actually query this data either from on or off-chain, depending on their use cases. To close the gap between Web 2 and Web 3 games, we also need some requirements that we want to enforce on our solution. And I gave them here, so there's 4 of them. So let's go into those. So the game data and queries need to be trustless, right? Because we don't want to have one central party that would be able to manipulate the game data. This would be a disaster. Think about these prediction markets, for example. If one party would be able to manipulate this data, they can get away with all the money. So that's obviously not what we want. A second thing is that we cannot rely on games to open up their data all the time. And even if they do, they can take it away at a whim again. I think a good example of this was Reddit. So Reddit, like 1 year ago, had this open API that everybody could use for free. But then they closed it, and now you have to pay actually to use this API. So now developers are using it less, which actually hinders innovation. And then a third one is, obviously we cannot store data in the amount of terabytes a day on chain. That's just not possible. We've seen lots of progress on this space with data availability and with general storage solutions, but still we cannot do this. And then we also want to enable fast end-to-end data flows, right? Meaning that your Web2 game data should be available on the Web3 side as soon as possible so that you can react on this real-time Web2 game events. So towards this end, we developed this architecture at Playfi. I'll go deeper into that in the next couple of slides, but I already want to give you an overview of what we have here. So on the left-hand side, we have PlayChain, and PlayChain is our layer 2 rollup solution. It's a ZK rollup built on ZK stack, and it allows developers to build these gaming applications that then can connect with these oracles, and these oracles actually have the task to query data from Playbase. We also have an API, an Oracle API, that allows you to easily set up an Oracle and also manage it. And then we have Playbase, and Playbase is our solution to allow anyone to upload their game data, and actually any type of data, but we're focusing mainly on games in the first phase, to Playbase. And then in Playbase, this data will be stored in a decentralized way from where it can be used. For this, we rely on a decentralized set of node operators, and these node operators each can opt to run one or multiple module types, which each have a certain task. Now I will go into what these module types are and what they're here for. So the first module I want to show here is the AI module. So the AI module allows anyone to upload their game data to Playbase through this permissionless API and SDK. And once this data is uploaded, it will be transformed in this standardized JSON format by making use of these machine learning models. We can also train these machine learning models with an ML trainer, which is pretty cool. So if you want to update this model later on to improve it, you can. And this checks off two of our requirements. The first one is that we have permissionless data ingestion because we have a permissionless API and SDK that can be used by anyone. And then we also don't have to store data on chain because the raw data that was ingested, from that we only use the relevant data, which is actually generated by using these machine learning models. So it's actually the machine learning model that defines what will be stored later on, right? Then we have the storage module. The storage module kicks into action once the AI module is done, and it will take the JSON files from the AI module and store it in this decentralized NoSQL database structure. This contains some collections where these JSON files are stored, and we also have an API that can be used to fetch this data again from the storage modules. So instead of needing to store this JSON file in some sort online, on chain, we can actually store this in our own storage solution. And the nodes that run these storage nodes or these storage modules will actually be paid for that in our native token called Play. And we have a fast end-to-end data flow because this NoSQL database solution in a distributed way is actually tailor-made to fulfill these very fast queries so that you have very fast response times as well. Then we have the ZK module. The ZK module is important for us for actually resolving query requests. So how this happens is that query requests can come in either from on or off chain. And once the request is in, the ZK modules will fetch data from the storage module. Remember that this module that I discussed a slide ago. And once the data is in, the ZK module will create a response or try to generate a response for the query. And once the query result is generated, the zk module will also generate a proof for that. And this allows us actually later on to prove that the result is correct without having to expose the data that was used to generate the result, which gives us trustless game data and queries. We also have a dedicated team working at PlayFi to actually make sure that we have the most performant queries that we can, circuits that we can get. Then we have the coordination module. So the coordination module has a lot of tasks and is actually the heart, I think, of Playbase. So let's start with the first task. So the first task is actually, once the AI modules are done processing, these JSON files will actually be hashed in some sort of fingerprint, and these fingerprints will then be compared to make sure that the data is correct. Then the fingerprint will be stored on-chain, on PlayChain, and the JSON files will be stored on the storage module. A second thing, I'll come back to this later once we talk about fingerprints. The second thing the coordination module does is act as a proxy between PlayChain and the zk modules for routing the queries, query requests to it, but also for routing the results together with the proofs back to PlayChain or to the requester in general. And then the last thing the coordination module does is actually make sure that all the nodes in the system are aligned. And it does this by enforcing that all the nodes in the system actually stake a certain portion of ETH, but also play in a certain ratio, so that we can actually reward nodes that are doing their duties correctly, but more importantly, make sure that the nodes can also be slashed, that they can be punished by being slashed if they don't behave correctly or if they act maliciously. And for this, we will run an actively validated service on top of either Eigen layer or Symbiotic or a similar protocol. We're still looking at which one we will be using. So the fingerprints guarantee us data integrity throughout Playbase, and the staking and slashing mechanism also gives us the trustless node setup. So this means that we have trustless game data and queries on this side as well. Then we have the verifier contract. The verifier contract acts as a gateway kind of between PlayChain and Playbase. So what it does is once oracles do query requests, the PlayFi verifier will pick it up and they will transform it in an event, and this event will then be picked up by the coordination modules. Now the other way around as well, once the coordination module has the result together with the proof, this proof and result will be stored on the verifier contract, and the verifier contract will actually verify the proof to make sure that the result is correct. And next thing it does is make sure that the fingerprint of the data is checked, of the data that was actually used to generate this query result, so that we can maintain data integrity. So this complete solution actually allows us to only store the strictly minimal data needed for the consumer gaming applications on-chain instead of the complete raw data of the games that we would have need to store or use otherwise. A little word about PlayChain. So PlayChain is built on zk stack. It's a zk rollup solution, and it's also part of the Elastic chain, which is this new framework of Matter Labs, which allows us to do native integrations with other zk chains in terms of functionality, but also in liquidity. So that's pretty cool. Definitely check it out. We also have very cheap Oracle updates, and why is that? That's because we can make use of state differences, state diffs, because we use because we use it in patches that we settle on L1, meaning that we only have to pay the state differences between the beginning and the end of the state. So if you do multiple Oracle updates on one slot in the same batch, then you only have to pay one, meaning that the more Oracle updates you do, the cheaper it gets, which is pretty cool. We also have native account abstraction and paymasters, which is actually a natural fit for gamers, right? Because gamers really don't want to fiddle with managing their own wallets or their own addresses or trying to think which ERC20 tokens they need to use for all these applications. Now instead they want a simple user experience to create their own account by using their social login or even with their face IDs. So that's also what we have and what we provide. We have very fast finality times, which can be counted in order of hours instead of days, like it is the case for optimistic rollups, because we are a zk rollup. And in the future, we will have ultra-high TPS, which should be reported around 20,000 TPS, according to Matter Labs, because this is the builder actually of the zk Porter solution that we will use. And we will run it in volition mode as well. So yeah, that's a call here to let's close the gap together. So as I told you, we're in need of this decentralized set of node operators, which each can run one or multiple of these module types. And you can actually run these module types on any type of consumer-grade hardware. Well, I should say the most recent ones, not like ones of 10 years ago, obviously. So if you're interested, we're hosting a license sale because you need a node license to run these nodes. We will host it probably during the end of August, beginning of September, but to be discussed yet still. So if you want to have any info about that, you can go to playfi.ai/nodes for any information on that side. So yeah, I think this was my talk. I hope you enjoyed it. If you have any questions, shoot. Yeah.
Thank you very much, Simon. Who would like to ask a question? There we
go. Thanks for your presentation. And I wonder what support, what operation of query of data query, and do you support? Does your protocol support? I mean that's often database. And the client could query the database for some operations. So which operations does the CRUD operations? So which operation do you support?
I'm going to. Is your question like which type of operations can we do to Playbase from the blockchain?
Not the operation to do on Playbase, but the operation to perform on the database.
Yeah, we have it's like a NoSQL type of database, so you can expect to use like any type of NoSQL compatible queries to be done on this Playbase side.
Oh, but do all the operations could all these operations be supported by zk, be protected by zk proofs?
Yeah, so for these operations, for these NoSQL operations, we're actually trying to get the circuits running, so that we can actually prove these specifically. So if we later on want to extend it out of NoSQL, then we'll have to do like some new research to make sure that we can support these circuits.
Oh, I got. So the database is still under construction, is right? Further research is required to build it.
Yeah, okay. to give you, because I didn't highlight this in the topic, but like our Playbase will go live on testnet probably somewhere in September. Yeah. And the play chain is actually already live on testnet, so you can already play with that.
Okay, I got it. Thanks for that.
Thank you very much for your question. Who else would like to ask a question? We have time for one more.
So I understand the data doesn't have to leave the storage nodes to go out to the users because you can use the proofs. How do you ensure that the data is being stored by the off-chain nodes?
Yeah, we'll make sure of some systems as well to make sure that like the data is always guaranteed to be available. So we'll have these foolproof, I can't come up with the name right now, but these systems where you actually make sure that the data is not all stored on one node, but like it's spread over multiple nodes, right? And also we make sure that the nodes are paid in display token, so that they're actually incentivized to be online all the time. And if they are not online, this means that they would actually be partly slashed as well. So actually to incentivize them to go offline if they're not running anymore. So that's how we plan to do it. But obviously, we need this decentralized set of node operators. So the more decentralized we are, the better. Yeah.
No. Yeah.
Thank you very much.
All right.